Hey guys, sorry I'm not in class today. I really wish I could be there, but I'm home with a sick kiddo. Anyways, I'm going to be back tomorrow, but I figured this would be the easiest way to teach the lesson to you, just so that way you are learning it from me and not from the sub. We're getting into three-dimensional figures, spatial reasoning this unit, and we're going to start off with solid geometry and talking about all those pieces. So the first thing we need to talk about is all the pieces of a three-dimensional figure, starting with the face. A face is going to be that flat surface. It can be anything that's flat. It can be round, it can be a polygon, it can be a quadrilateral, whatever you want it to be. An edge is going to be a line formed by the intersection of two faces. The key is lines are straight. And a vertex, which is the point formed by the intersection of three or more faces. So as you can see from the picture here, the face is in pink, the edge is the red line, and a vertex is the point at that corner. So then we need to talk about all the different types of polygons. And as for those of you who haven't done this through a video before, feel free to pause anytime you need to get some stuff down. So the first type is a prism. A prism is made up of two parallel congruent polygonal faces called bases, connected by faces that are parallelograms. The key here is that these are named by the shape of the base and not by the other pieces. So it doesn't always sit on its base. We've kind of talked about that in that I can be sitting down, but my feet are still my base. Then the next one we have is a cylinder. The cylinder has two parallel congruent bases, but they're circular, and a curved surface, which is not a face, that connects the bases. The third type is a pyramid. A pyramid is made up of a polygonal shaped base. It can be a triangle, it can be a square, it can be a rectangle, it can be a pentagon, a hexagon, octagon, whatever you want it to be. And the faces are triangular that meet at a common vertex. It does not have to be upright, it can be slanted as you can see in this picture. Fourth one is a cone. A cone is made up of a circular base and a curved surface that connects the base to a vertex. Cones do not have any edges, neither do cylinders. Cylinders have two faces, cones have one, and those faces are the base or bases, which are circular. The final one is a cube. Cube is simply a prism with 6 square faces. It's a rectangular prism, but it has those square, you can also call it a square prism. So here are some shapes of some of the other prisms and pyramids and the specific name. So we've got triangular, rectangular, pentagonal, hexagonal. That's about as far as I will go when it comes into getting into calculations and really for drawings too. And so they're named because of the shape of their bases, which they happen to be sitting on. And then it's likewise triangular, rectangular, pentagonal, and hexagonal pyramids. Notice they have points. You have to look at the shape of their faces if they're rectangular versus triangular. All right, now let's look into some of the work. So the first thing we got to be able to do is classify the figure and then name its vertices, edges, and bases. We look at this first one. I recognize this as triangular faces, so it is a pyramid. That base right here is a rectangle. We don't know if it's a square or not, so we're going to go with rectangle. So this would be a rectangular pyramid. If you haven't figured it out yet, yes, today is going to be a lot of writing. Vertices. I see that we have points A, B, C, D, and E. We got to include that vertex up top. And like we remember from Unit 1, vertices or points are just written with a letter. Then we have to look at edges. We have an edge from A to B. Don't forget the line over the top. If you don't have the line over the top, you will get docked points. We have from B to C. We have from C to D. We have from D to A. We also have the ones going vertically up to the common vertex. So we have BE, we have AE, we have CE, and we have DE. You you count the edges, then you make sure you got them all. And then we have one base here, and I'm going to call it, I'm just going to make the shape for a quadrilateral, so quadrilateral, or you could call it just write quad, and it's ABCD. So pretty straightforward. Next, we have a soup can. A soup can is the shape of a cylinder. Vertices, we have none, so we write none. We don't just leave it blank, because blank implies you don't know. None actually tells me you understand there are none. There are also no edges, because edges have to be straight. And then we've got two bases. We could say the word circle. If you want to abbreviate it, you can make a circle with a dot in the middle. You can't just leave it without the dot, because otherwise it looks like an O. So then we have circle P and circle Q. All right. I want you to take a minute and try these two out, and then hit play when you're done, after you've entered your information into the Edpuzzle. That's the great part about it, and then we'll check them. All right, let's check our work. We have a cone here, and I can tell because it's an ice cream cone. Vertices, we only have one, and that's point N at the top. We don't have any others because of that curved surface. We have no edges. And the base, this base isn't labeled, so let's go back in and we can call it E. So we're going to call it circle E. I apologize for not getting that to you sooner. All right, and then D, we have rectangular faces, so we know it is a prism. And then it's got triangular bases, so that is a triangular prism. Vertices, we have T, U, V, W, X, and Y. Edges, we've got 3 around the top base, 3 around the bottom base, and 3 to connect the two bases. So that means we have 9 total. So that means we have from T to U, U to V, T to V. And I usually go in a pattern, so I went on the top base, and I'm going to go on the bottom base. W to X, X to Y, Y to W, or W to Y, however you want to look at it. Then we go between the bases. We have T to W, we have V to Y, and we have U to X. And then finally bases, we got 2 triangular bases. So I'm going to use the triangle symbol instead of having to write it. We got TUV, and we got triangle WXY. That's the first part. Next part, we've got what's called a net. A net is, I know this is long, it's a diagram of the surfaces of a 3-dimensional figure that can be folded to form the 3D figure. To identify the 3D figure from a net, look at the number of faces and the shape of each face. So before you freak out about how long that is, I'm going to shorten it for you. A flattened version of a 3-dimensional figure. And then you do want to put this second part in your notes. So really you have 2 pieces. You have to be able, or 3 pieces. You have to be able to name the figure, you have to be able to describe the shape of the cross section, and draw a net. So I look here, these are all triangular, and therefore I know that triangular is going to be in my name. And because they're all triangular, that tells me that it's a pyramid. This one has round bases, so I know it has to either be a cone or a cylinder, and we got this rectangular surface here that makes it a cylinder. All right, next we got something called the cross section. The cross section is what it is the intersection of a 3-dimensional figure and a plane. Basically, it's if you were to take like a sheet of paper or a blade or something and cut it through a 3D figure. What shape does it make? So you cut through a block of cheese, you open it up, and tell me what shape you see. So you have to be able to describe the cross section. This plane right here, or that figure, that rectangle, has cut through a hexagonal prism. And based on the way it's cut, this is going to produce a hexagon shaped for the cross section. And now we have a cone. If we cut that cone from top to bottom, we're going to have a triangle. Now it won't be another cone because when you look at a cross section is two-dimensional. So it will either be a triangle, a rectangle, a pentagon, a hexagon, an octagon, depending on what shape you have there. It might also be a circle. So another would be if you drew, if I said, I'm just going to real quickly, if you've got a three-dimensional figure, yes, I just drew that by hand real quickly, to be able to draw this out and tell me that that's this would be your net, and be able to label it with dimensions if I gave them to you. So there you have it. I realize it was 11 minutes, but that'd be a whole lot longer in class. Now you can go ahead, submit these notes if you'd like, and then once you've submitted the notes, you can get a packet from the sub and go ahead and get started on the 10.1 assignment, and we will see you tomorrow.